Hello, welcome to the session on Accelerate Spring Apps to the Cloud at Scale. My name is Adib Saikali. I'm a principal platform architect with VMware, came through the Pivotal acquisition. I am a software developer, and my customers like to call me the code janitor because they frequently say, hey, here's a large application. Can you tell us how to take this application and take it to the cloud? Today, we've assembled a wonderful panel with our friends from Morgan Stanley, Bosch, and Digital Reality that are going to talk to you about how they're using Azure Spring Cloud in production. We're going to start off the session, though, with an overview of the architecture of Azure Spring Cloud and a demo to get you to see what the developer experience is like, so that when the panelists are providing you with wonderful details about what they're doing, you'll be able to kind of understand that in the context of what the user experience will look like.
I'm Asif. At Microsoft, I'm on point for everything developers and customers need to build, migrate, and scale Java applications on Azure. I'm also a Java developer. I started in 1995 with JDK1 and have been having an amazing time with Java ever since. So, what is Azure Spring Cloud? Azure Spring Cloud is a fully managed service for Spring Boot applications that lets you focus on building and running the apps that run your business without the hassle of managing the underlying infrastructure. You can simply deploy your jars or code, and Azure Spring Cloud will automatically wire your apps with Spring Service Runtime. Once deployed, you can easily monitor application performance, fix errors, and rapidly improve applications. It's fully integrated into Azure's ecosystem, and it's ready for the enterprises. The service is jointly built, operated, and supported by Microsoft and VMware. A little more details. The big rectangle is Azure Spring Cloud. It is built on Kubernetes, particularly Azure Kubernetes Service. Each service instance has 2 dedicated Kubernetes clusters. They are managed by Azure Spring Cloud and fully abstracted away from users. Service runtime with managed Spring Cloud components, log streaming, app lifecycle, and many more service runtime components are managed in one of the 2 Kubernetes clusters. It is the one represented on the right side. Your apps are running in the second Kubernetes cluster. It is represented in the left side box in the diagram. Your apps can interact with any Azure service or external service or on-premise systems. Logs, metrics, and alerts are available through Azure Monitor. You can pick them up using Elastic, Splunk, or Azure Log Analytics. You can secure your apps using Azure Active Directory. You can automate end-to-end from idea to production using your favorite tools and platforms. You can continue to use your development tools that you're familiar with, from IntelliJ, Eclipse, VS Code, Maven to Gradle. Everything is supported. Net, it's an easy way to get started, focus on your business objectives, and everything else is taken care of for you in the cloud. Do you have to manage anything here? No, not at all. You don't have to manage anything. Azure Spring Cloud has absorbed all the complexities with infrastructure, hosting applications, app lifecycle, managing applications, blue-green deployments, publishing logs and metrics, and so on and on. Everything is taken care of. And all of these are supported by Microsoft and VMware. We'll show you a very quick demo of Azure Spring Cloud and show you how simple it is. Are you ready? Let's take Spring Boot applications to cloud at scale. I have an app composed of Java microservices, and I want to run them on Azure. This is a popular repo, a distributed version of Spring Boot Pet Clinic. You can see an API gateway as the entry point. The operator comes in, and there are 3 microservices and 1 Spring Boot admin server. We're going to deploy to Azure Spring Cloud. I took 3 simple steps to deploy to Azure Spring Cloud. I created the service, created apps, and deployed the jar files. You see an instance of Azure Spring Cloud for the Pet Clinic project. You can see the apps up and running at scale right now. API Gateway is the entry point. So I go here and start clicking this particular assign FQDN. At this point, I see the actual application coming up. I can see all my customers and their pets as well. You can see John Coleman has about 2 pets. I can also see my dogs here. I can also start scheduling visits using this system. So here, when I open up John Coleman, you can see that he has two pets, and I can start adding a visit right here. When I deploy these jar files, I do not have to do anything other than just deploy them. Do we have enough instances of the customer service? Let me scale that out. Right now, there are about 6 instances. I can increase to say 200 instances, or maybe 500 instances. As soon as I save, it'll start scaling out. I can also autoscale. Here I'm looking at autoscale. Now I can autoscale by metric or by schedule. Let's look at the metric. In this, I'm scaling out by the CPU usage, right? Now here, when the app usage, CPU usage goes up by 50%, I'm going to ask it to increase the number of instances by 2. Similarly, when the CPU usage goes down, I'm going to ask it to, when it particularly goes down below 30%, I'm going to ask it to reduce the number of instances by 2. I can also auto scale by schedule. For example, I can scale in on Saturday morning and scale out on Monday morning again. So many things are managed for you. Now, what if there's a problem with your app, and how can you see what is going on? You can view the logs for all your apps and even run custom queries. You can send all your logs and metrics to any log aggregator, say Log Analytics or Elastic or Splunk. Here, I sent them to Log Analytics workspace. Here, I'm running a query and to bring all the logs for my applications, particularly the ones where I see errors and exceptions. I can quickly go through and open up one of these and understand what is going on. I can also render them as a pie chart. Now, if you're a developer like me, you probably want to get your logs directly on your dev machine here and say AZ Spring Cloud app logs. So when I run it, it will directly bring all the logs right to my dev machine. This way, I can figure out what went wrong. In this project, I used many microservices to scale out my components individually. You can use application insights to monitor which app calls are slow so that you can tune them or know when app instances are bombed out because of some production data that came in. So here you see the API gateway is here. The calls are coming in and they're going into customer service, and some calls are going into vets, and some calls are going into the visit service. Now behind them, there's a Pet Clinic SQL database, MySQL database, right? So let's zoom in. Let's say I want to drill into one of these paths, right? So I go here and I drill into one of those paths. When I drill in, it gives me some meaningful insights. It's giving me an option to investigate the performance. I can drill into it. When I drill, it gives me all the calls that happened in the last 4 hours. I can choose one of them and go deeper. When I go deep, it gives me the complete end-to-end transaction that happened along this path. And you can see all the way down to here is the SQL and the SQL query that that was executed for this particular operations. Now back to the application map. It gives you some incredible views of all your applications, meaningful insights, and actionable logs and metrics. Did you see 5 million calls in the last 4 hours? Yes, they are in production at cloud scale, running at 30 million calls per day. Now you can simply run manual scale slider or the auto scale to multiple billion calls a day in a matter of minutes. Now you can also go deeper into performance or failures and availability. So here you see the performance blade where all the methods are, all the operations are listed here. You can also look at the dependencies. So these are all the dependencies. So dependency calls were about, in the last 4 hours, there were about 40 million calls, right? You can also start looking at your failures, right? Now, you may have some business metrics. You can track them right here. Let's see. In this particular application, there are pet owners, there are pets, and there are visits. We keep track of them. That way you can see the rhythm of your business across time. Do you have to write any code for all these monitoring? No, not at all. I simply deploy my charts, nothing else. All these data flows in effortlessly. Azure Spring Cloud is a fully managed service for Spring Boot apps that lets you focus on building and running the apps that run your business without the hassle of managing infrastructure, monitoring, or automation, or app lifecycle, and so on. Today, Adib and I invited a great set of panelists from Morgan Stanley, Bosch, and Digital Reality Trust who have been very successful in adopting Azure Spring Cloud and accelerating their Spring Boot applications to cloud at scale. We are very excited. Let's start with an introduction.
Hello, everyone. My name is Dhiren Shah. I'm part of operations technology at Morgan Stanley. I have two roles here. I'm a tech area lead for security settlements fleet, and I'm also the lead architect for operations technology. I'm leading a very talented and innovative team to build our next generation of security settlements platform. Security settlements platform facilitates movement of stocks and bonds between market participants based on trading activity. We process millions of messages per day in our global settlements platform across major financial markets. We have decided to approach this project in stages with the goal of developing a cloud-based message-oriented idempotent solution that can horizontally scale with separate data stores, command, and event handlers. For the first phase, we migrated from mainframe to Spring Boot apps. Second, we deployed Spring Boot apps to Azure Spring Cloud and ran a production parallel across a few selected markets. The final phase will be scaling to markets across the globe and sunsetting our mainframe systems. Azure Spring Cloud is at the heart of our solution, running modern Spring services for command and event handlers and also for reporting. We are also leveraging other Azure services, including SQL databases for storing business data, Key Vault for managing secrets and zero trust, Azure Monitor, Log Analytics, and Application Insights for end-to-end monitoring. And we also leverage Azure Networking for secure communications.
Hello, everyone. My name is Georg Deschler. You can also call me George. And I'm with Bosch since 2008. I've been working in various projects and positions there, including development, solution architecture, and project management. And currently, I'm a development team lead and agile coach for a really amazing team. And with this team, I'm developing and operating an IoT solution for tracking of shipping assets and materials. And it's called Track and Trace. Track and Trace can be used to track many kinds of assets. Today, as mentioned, our focus lies on customers that use it for logistics assets like containers of any size. They can save effort for finding their assets and save money by managing their empty assets more efficiently. Because it's quite clear, finding an empty asset is much cheaper than buying a new one. Now, how does it work? Someone on the shop floor attaches a wireless tag to an asset, which is continuously broadcasting its ID. They also create a logical link between the asset and the tag with a mobile app. Gateways are receiving these broadcasts and transfer the information to the backend. So you know where the tag is, and by that you also know where your asset is. Data is received by an application gateway and hand it over to the track and trace core system, which is consisting of about 15 microservices, which are running on the Azure Spring Cloud. There are many different views and reports based on the data that we present in our UI. And process data can also be sent to customer systems.
Hi everyone, I'm the principal architect within the IT infrastructure leadership team at Digital Realty, and I'm not a Java developer. My role spans across our cloud systems and network landscape. I favor repeatable, scalable, and secure architectural patterns. I've led the architecture and implementation of a large-scale, multi-region Azure Spring Cloud project this year, and my team is made up of a lot of different people like developers, business analysts, cloud engineers, and product managers. I'm an engineer at heart, and I love solving complex technology problems with creativity and elegance. Digital Realty supports the data center, colocation, and interconnection strategies of customers around the world, ranging from cloud and information technology services, communications and social networking, to financial services, manufacturing, energy, healthcare, and consumer products. We operate over 290 data centers in 24 countries and on 6 continents. The architecture on the screen is our design for a new platform for our customers that will allow them to build integrations and consume data from us about their services. Azure Spring Cloud is at the center of hosting these REST APIs that power the platform, and we leverage multiple regions for Spring Boot microservices. We follow a hub and spoke model. Our solution is fully automated end-to-end, including our virtual Palo Alto firewalls at the edge.
Awesome. Thank you so much for such a wonderful introduction. I'm just blown away by how awesome and how extensive your use of Spring Boot is, and also on Azure. So one of the things that I hear a lot from CIOs is, okay, this cloud is big, it's got a lot of services. So can you tell us a little bit about how does Azure Spring Cloud fit into your overall cloud strategy? And what were some of the considerations in selecting the Azure Spring Cloud service?
We leverage Spring frameworks for most of our development, and Azure Spring Cloud is at the heart of our strategy for implementing global security settlements platform. We are leveraging open source technologies, and multi-cloud portability is a key design principle. Improving developer productivity is one of the goals of our transformation, and Azure Spring Cloud contributes towards that goal by taking away the complexities of managing our own Kubernetes cluster. Azure Spring Cloud allows us to focus on implementing complex business features and not having to keep our infrastructure up to date. We use automatic containerization from Spring Boot source or jars, which allows us to define a roadmap for modernizing on-prem applications to cloud faster. Azure Spring Cloud makes it very easy for us to configure, deploy, monitor, and scale our applications, and also handles the lifecycle management. With the ease of automation and ease of monitoring that comes with it, we have been able to scale our development team without compromising code quality and robustness of our application. Azure Spring Cloud is at the heart of our platform. All our command and event handlers are deployed in Azure Spring Cloud.
Well, we also didn't have much interest in getting involved with Kubernetes, Docker images, and the like. For a team that's focused on development and that has been previously working with Cloud Foundry and its build packs, Azure Spring Cloud was an attractive option. Now, in the meantime, we've migrated about 15 microservices, as I said, to Azure Spring Cloud. And we still want to use the major share of the team's capacity for further development of our product. And so it's really helpful not having much more to do than building a fat jar to get the service deployed. We weren't sure if this would also work for some of our services that are still based on Vertex, but it does. And so we were able to move the complete solution to Azure Spring Cloud as our single runtime for the services. Another important thing for us is scalability from a business perspective as well as technically. Track and trace is still growing, and we're placing many more tracking devices in the field. The monitoring functionalities are very valuable, not only to identify issues during daily operations, but also to see which parts of the system we need to focus on to allow our business to grow.
So if you're listening closely, there's a trend here. We also selected Azure Spring Cloud because we didn't have the skill set or the desire to manage Kubernetes. And we also wanted to be able to start development almost immediately without long runways of setting up infrastructure and networks. Azure Spring Cloud allows us to scale horizontally, quickly, and easily, and we leverage several sets of ARM templates for new region deployments globally, including fully automated management of virtual Palo Alto firewalls and a baseline of VNet peering rules. Currently, we have around 30 Spring Boot microservices deployed to Azure Spring Cloud across 2 regions, and we aren't even in production yet. When it's all said and done, we anticipate having somewhere in the neighborhood of 90 microservices within our current scope for our project.
For cloud strategy, I like how you approached it from portability, productivity, and faster time to market, and then chose Azure Spring Cloud, where you can focus on your business without worrying about the underlying infrastructure. To recap some of the key points what we heard today, Azure Spring Cloud is fully managed service by Microsoft and VMware. It is built on Kubernetes. You don't have to learn or manage Kubernetes. It's easy to create, configure, deploy, monitor, and scale. As we saw today, Azure Spring Cloud is the heart of Morgan Stanley, Bosch, and Digital Reality Trust architectures, and the service powers Spring Boot applications for them. Day in and day out, our customers and developers tell us that security is a critical consideration for any enterprise applications. So we love to hear, how do you enforce security policies across your Spring Boot applications?
The architecture of our Spring Boot microservices follows application development best practices, DTAP, cloud and network security best practices of segmentation, and a zero trust model. Cross-environment routing is disabled, for example, forcing the use of the release pipelines. We leverage managed identities, certificates, access policies, and key secrets inside of segmented Azure Key Vaults by environment. Our application then follows the RBAC model, and each end user or machine is authorized via claims. All of our code is scanned as part of the pipeline for credentials using Veracode.
As a financial institution, security is extremely critical. Our dedicated team of cybersecurity experts is drawn from former senior professionals at government security agencies and the technology industry. I think all developers should be thinking about how we make each interaction secure and think through various threat scenarios. This is very important for building secure cloud-native applications. We implement every application in a landing zone with RBAC policies that are reviewed by a centralized tech risk team to ensure consistency and strength of controls. We use infrastructure as code to configure these services to mitigate any risk of human error. We handle security at multiple levels in our solution. We are leveraging concepts like network segmentation and VNet peering capabilities of Azure Spring Cloud. We also use private endpoints as another network control. Implementing zero trust based interactions model, which assumes nobody is trustworthy by default, even though already they are inside the network segment. We are leveraging Azure Key Vault to manage our secrets. We encrypt all our data in transit, at rest, and in use. We have shorter expiration durations for our identity tokens, as well as we do frequent certificate rotations. We also have checks in our build pipelines to ensure any secrets don't leak out via code repository.
For Bosch, security is an undisputable quality requirement of our IoT solutions. And that's why we have a process in place that we follow to ensure it's considered sufficiently in software engineering. So this has really also the level of a central directive. Now, to make application of measures even easier for the teams, we have a corporate implementation guide for Azure that our central IT department elaborated together with Microsoft. This tells us how to use Azure services properly to reach the required level of security. So, for example, it tells us to use a certain service tier to be able to use the VNet integration, or it tells us how to set certain configuration parameters to have a service properly in place. We also implemented the reference architecture for Spring Cloud as it's recommended by Microsoft. Azure helped us together with some guys in Germany, and I think you remember Azure reviewing our architectural ideas and giving us feedback how to do it. That was also very helpful to build it in a reasonable and secure way. So, among other things, we realized network segregation, keep our secrets in Key Vault. We use managed identities, of course, encrypt data in transit and at rest. And important to mention, the respective policies and measures are implemented using Bicep. So we make sure they are incorporated on provisioning the services. Additionally, we are also able to trace requirements from our implementation guide, or also additional requirements we make up on our own, simply by commenting these scripts properly.
Awesome. Wow. I mean, this is pretty impressive. What I'm hearing from you guys is that you're able to build on top of the existing security processes and apply some of the best practices. In particular, like, if we kind of recap it, I really love how you guys talked about how you're able to isolate your services and apps from the internet, how you're able to do zero trust and integrate into the Azure RBAC system, use private endpoints to connect to things, and encrypt all of your data at rest and in transit. And really the comment about how developers have to think about security and be part of it, can't agree more with that. So this is truly nice. So when we do this, we secured our applications. The question now is that are applications available? So how do you handle end-to-end monitoring of your application, and what tools are you using to do this?
Yeah, so for us, the security settlements platform is a very critical platform, and if availability is very important. So we have a lot of real-time monitoring implemented for that. We use application insights to collect our application logs, traces, and metrics with open telemetry for log correlations using traces and spans. We leverage the application map functionality in App Insights to spot performance bottlenecks for failure, as well as identify issues with latency. And it allows us to kind of monitor the health of the whole platform, as well as drill into any issues that are ongoing. We use Azure Monitor for querying the collected telemetry information, and we have integrated with leading observability players to enable monitoring and alerts and automated notifications for any issues to be resolved. We also use our logs to measure processing rates and response rates to maintain our SLOs.
Yeah, we also use application insights and log analytics. We have alerts configured for critical metrics, and we have dashboards for a quick overview. For our team, alerts work quite simply. via email, or what we also use for really urgent incidents. We have some webhooks that can send direct messages to the members. With log analytics, we are also able to handle our logs very similarly to our old environment, where we used another logging and monitoring platform, but it worked similarly in terms of querying the logs. So learning Custo as a new language isn't too difficult to get for the team. For checking the health of our apps and investigating issues, we found the application map to be very, very useful. This was a real wow effect for us when Azure showed it to us the first time in the call. It draws our attention to the right spots, certain services, or also the interaction between them. And then when we see something turning red in the application map, from there on, we're able to dig deeper by just clicking on it, and we identify issues that way. This helped us a lot directly after migration to identify some configuration issues and bottlenecks that we couldn't find with our tests.
We also use Azure Monitor, App Insights, and Log Analytics, and those are central to our application monitoring. The DevOps team receives Webhook Actions in Teams for critical log alerts so that they can be actioned immediately. We have a vision to go beyond traditional monitoring and incorporate self-healing technology and event aggregation, leveraging products such as Moogsoft and App Dynamics to adopt a more event-driven architecture.
I really like how you have set up some real-time end-to-end monitoring dashboards. As I was watching those monitoring graphics, we can see that you have some incredible views of your systems, some meaningful insights into your business as seen through the system, and with some actionable logs and metrics. It's also amazing how you can dig deeper into those issues directly from the dashboard. To recap, you can monitor your Spring Boot applications and end-to-end solutions, including all the Azure resources and your on-premise resources around Azure Spring Cloud. You can monitor apps and end-to-end solutions using any platform and tools of your choice. You can troubleshoot your applications, measure SLAs or SLOs of your solution, just like the way Dhiren explained. You can plan capacities by running your performance, establish baseline for everyday workload and peak workload, just like the way George explained. And you can keep an eye on production, just like the way Tiban explained. And of course, you can use App Insights, New Relic, Dynatrace, or App Dynamics, Log Analytics, Elastic, or Splunk. Today, we learned a lot about different architectures by Bosch, Digital Reality Trust, and Morgan Stanley. It looks like you have different drivers for scaling your applications. We heard about IoT devices, trades, and end users. How do you scale your applications? And what is driving that need? What types of approaches do you use for efficient use of resources in the cloud?
Yeah, Azure, I think you already guessed it. As we have an IoT application, the number of connected devices is the primary driver for our scaling needs. Data is transferred from the devices to our backend at a quite constant rate. That's why so far we're quite happy with manually scaling the app. Yet, this is not a trivial task. There is quite some processing and enrichment going on in the backend with the raw device data. And to determine the needed capacity for the different microservices, we are running load tests regularly. And with these load tests, we are simulating a number of devices we expect in the near future on our QA environment. And then we check the system health using the application map again. that we saw before. So when we see something red there or poor performance between services or something, we configure the service instances until everything runs smoothly. Of course, we also stumble upon parts of the system that could run more efficiently, where you maybe don't want to throw resources just to make them go, but where you say, oh, we could improve something in our code. If we find these places, we think about the necessary changes, derive them, and place them in the backlog for further planning. And then our product management simply needs to prioritize them versus, let's say, new features or something. Additionally, we also use Azure Cost Management to keep track of the budgets so we don't get surprised by huge bills.
Our architecture was designed in a way to scale globally because our customers are literally everywhere except maybe Antarctica. For efficient use of resources, we rely upon auto-scaling in our upper environments and leverage features in Azure Cost Management to establish spend thresholds and alerts. We're working on identifying a long-term strategy for log retention to minimize log analytics costs and also to be in compliance with corporate retention policies. Spring Boot microservices will be the engine behind a new product launch for the company, and we anticipate very heavy loads. We're modeling multiple different volume trends based upon current usage insights from existing products by performing regular load testing with JMeter. Our load tests are originated from several different geographical locations around the world and also from multiple device types, including cell phones, tablets, virtual desktops, and machine-to-machine.
The average number of trades varies per day. This can be driven by various economic events and company-specific news. We also have cutoff times for various markets, and we generally see a spike in activity happening towards the cutoff time with end of day and the volumes increasing there. So from a scalability perspective, we have to look at two angles. One is how do we handle the varied volumes day over day, plus the spikes towards the cutoff times. And second is as we deploy additional markets and onboard new flows onto our platform, how are we going to scale out? When we first started the project and built our framework, we ran performance tests to define what we call as the scale unit. And as we roll out new markets, we are going to make decisions on how we leverage that scale unit and make sure we can handle the increased volumes. We also have implemented geo-redundancy in our platform, and we run our apps in a very scaled down version in the secondary region. We will be configuring auto-scaling Azure Spring Cloud apps based on depth of incoming subscriptions. And we have also enabled financial transparency to monitor the price of our cloud usage.
Wonderful. I love how you're able to use Azure Spring Cloud to handle your short-term scaling needs with the auto-scaling capabilities, and that you're able to handle your business growth and scale up your applications as that grows. So we all know that scaling is part of the solution, but it's also important that we scale the humans and that we're able to automate things. So can you tell us a little bit about what automation tools you're currently using with Azure Spring Cloud?
Yeah, sure thing. I'm sure for all of you listening, you can relate to this, but we have to move fast. Our business is rapidly growing, and we struggle to keep up with workloads that require manual processes or intervention. Also, standardization is nearly impossible if application and infrastructure are not automated, repeatable processes. Azure DevOps build and release pipelines are our primary way of automating and managing the environments directly, and we do leverage ARM templates. Our pipeline architecture includes automatic code scanning with Veracode, and we're working on integrating Azure DevOps with ServiceNow for complete end-to-end automation of production releases for compliance adherence, but also for ease of promotion.
We use infrastructure as code and Terraform for everything. We have multiple environments fully managed by infrastructure as code. We have implemented robust CI/CD pipelines with different levels of automated testing. And this includes chaos testing as well as deploying in an ephemeral environment and running end-to-end acceptance tests. Our deployments are 100% automated using Azure DevOps pipelines. And this includes creation and configuration of all the Azure resources. We also do staged zero downtime deployments, and we have already seen benefits, right? Like where we have increased our release cadence from monthly to weekly. And just a couple of weeks ago, we did a release on demand to address an issue. As I mentioned, we started with a smaller set of developers, right? And now we have scaled out our development number of developers on the team. And they are implementing different flows in parallel using the same code base. And we want to stay conformant with our architecture principles, and we want to make sure we can deploy good quality code with confidence. So automation is very, very critical for us.
Yeah, I fully agree with what Diwan said. Speed is key. We want to deliver fast, but also in high quality. And this is a clear QM requirement to us. We need a high automation level to be allowed to do continuous delivery as a team. Therefore, we have multiple environments. We use Bicep to describe them, and so we are able to provision them automatically. We use different pipelines on Azure DevOps. One for the provisioning that I just mentioned. The next one is for continuous integration on our QA environment. This is done whenever the master branch of a service is changed. Then we automatically build it and deploy it to our QA environment of Spring Cloud. This includes at least automated unit tests on build. We also have automated system tests that are quite time consuming. We need to simulate some real timing behavior there, so they run for some hours, and we run them nightly. We have also one pipeline scanning code and dependencies for open source compliance and vulnerabilities. And last but not least, we have release pipelines for every service that allow us to deploy to production and run smoke tests automatically.
It's really great to see how you all have automated end-to-end. Digital Reality uses ARM template, Morgan Stanley uses Terraform, and Bosch uses Bicep for automated provisioning and configurations. You all are using multiple pipelines using Azure DevOps. You also automated testing and delivery of services. That sounds great. Now, anyone can build end-to-end automation from idea to production using a wide range of tools and platforms. Typically, just like Morgan Stanley, Bosch, and Digital Reality Trust, we see developers create pipelines, multiple pipelines that are broadly classified into three categories. The first one, provisioning pipelines. You can provision Azure resources using Terraform, ARM template, CLI, or Bicep. Build pipelines. You can build using your favorite Maven or Gradle and store it in an Artifactory. Deployment pipelines. You can use GitHub Actions, Jenkins, Azure Pipelines, and Azure CLI. Blue-green deployment strategies are very popular for minimizing the downtime. When we were staring at your architecture diagrams, we saw that you were leveraging many services and on-premise systems to build holistic solutions. So what are some other requirements of your applications?
Our application is a mission-critical application with a lot of complex business functionality required. The transformation program we are running is not just a technology migration. We are looking to add significant capabilities which will drive end-user efficiencies. When we started the program, we made a decision to take an evolutionary approach to evolve our architecture, which means we will be introducing new services that allow us to deliver required capabilities with low or no code implementations. Currently, we use Azure SQL, Azure Key Vault, Service Bus, App Service, and Storage Account. We have already started integrating Azure API management into our stack. We use Azure SDK Spring Starters for Java to interact with Azure resources. Our partnership with Microsoft is helping us to get new capabilities in Azure services. Azure has been helping us getting some new features in Azure Spring Cloud to keep our implementation simple. Our goal is to maintain our architecture principles as the ecosystem and our implementation evolves.
Yeah, it's about a month now that we finished our migration to Azure. And after that, we currently use Azure SQL, Service Bus, Redis Cache, Application Gateway, Storage, Key Vault, and some others. And now we're starting to investigate which services we could integrate into our architecture for improving certain parts of the system. Our main drivers for this are, again, future reliability and scalability requirements. And we really also see promising opportunities there. But to be honest, at the moment, we're primarily happy that we made the step over there, and now we will take our time to investigate what else can be useful for us.
Our key requirement is resiliency and scalability. We need to be able to support a minimum of 25 million API calls per month. We have an availability SLA target of 4 nines for our entire platform because it's deemed business critical to our customers. Azure Spring Cloud is just our microservices layer of a broader platform architecture. These microservices are sourcing data from endpoints and other public clouds, as well as on-premises resources. Our latency target is to be sub 20 milliseconds, all fronted by an external but cloud-native API platform. We leverage cloud-to-cloud peering for resilient, fast connectivity between our public clouds and multiple Azure Express routes, in addition to private Microsoft backhauling within the Azure ecosystem between regions. Some of the other services that we use are the Azure App Service and Plan, Cosmos DB, Redis Cache, Azure Front Door, Key Vault, Event Hub, and JIT.
I like how you have taken advantage of a range of services to build holistic Java and Spring solutions, particularly database, cache, storage, service bus, vault for secrets, load balancers, and network elements. Thank you. Thank you for explaining the purpose behind these choices. Java and Spring on Azure is a holistic solution that brings together many Azure services. Microsoft and VMware brings the expertise of running enterprise Spring workloads at scale. Azure offers a differentiated portfolio of managed databases to serve Java applications of all types. You can enable asynchronous messaging at cloud scale in Java apps using Service Bus and Event Hubs. You can secure access to your Spring Boot apps using Azure Active Directory. You can set up end-to-end monitoring using any monitoring platform or tools of your choice. You can automate end-to-end using automation tools or platforms of your choice. You can secure your workloads by isolating them from the internet and secure them by applying many of the policies that we discussed today. On behalf of Atif and myself, thank you, Dhiren, George, and Divan for joining us and sharing all the details. your experiences and insights. It's truly inspiring to hear your journeys to production and how you all have navigated through Azure services, particularly Azure Spring Cloud, framed cloud strategies, enforced security, set up end-to-end monitoring and automation, and built holistic solutions for your workloads. Also, happy to see that you have used tools and platforms that your teams know and familiar with. Everyone watching today and anyone can build cloud-native solutions and advance them to production. We love to hear how you are building impactful solutions using Azure Spring Cloud. You can get started today. You can deploy your first Spring Boot app today. You can also use a self-paced workshop to learn the details of the service. If you prefer videos, we have some bite-sized videos part of the YouTube. You can simply follow the playlist. You can also leverage best practices for deploying Spring Boot apps. You should let us know how you are building impactful solutions. Microsoft and VMware announced Azure Spring Cloud Enterprise. If you are interested, then please sign up. You can scan the QR code or go to that URL. That will take you to the registration form, and please click Contact Me there, and you will receive information to activate the private preview. Everybody on the live stream, thank you for joining us today. Thank you.